Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, we are going to learn about p block element. You know friend, p block element is also in 10+2 and for NET, GATE, JAM examinations. So I will talk on fundamentals of p block elements. So let us start. You know elements which is last electron enters p orbitals. This is the definition of p block elements. Our general electronic configuration is NH2NP1 to 6. Exception of helium atom number 2. So it located right side of periodic table. So friends, atomic radius comparing gallium 135 picometer to aluminium 143. General electronic configuration is NH2NP1 to 6. Atomic radius decreases but aluminium less than gallium. Due to d electrons, you can see aluminium 13, 3s2 3p1 and gallium 31, 3d10 4s2 4p1. So this is the difference. Now friend, inner pair effect. You know the phenomenon of electron remaining paired in the valence shell. Inert pair effect increases in a group, top to bottom. Boron and aluminium oxidation stage +3, which gallium, indium and thallium +1. So more stable BCl3 or TlCl3. You know boron 2s2 2p1 light element, Tl 81 4f14 5d10 6h2 6p1 heavy. So boron anomalous behavior +3 oxidation state and thallium large size and inert pair effect and from more stable +1 oxidation state. So friend, you know the Lewis acid tendency to accept a pair of electrons to achieve a stable electronic configuration are Lewis acid. In trivalent state, the number of electrons around central atom will be 6. Down the group tendency to behave as Lewis acid decreases. So look at here. BCl3 act as Lewis acid by accepting pair of electrons. You can see ammonia have lone pair of electron, BCl3, one bond length is 174 pm. Now after forming a duct, you can see this bond length increases from 174 to 184 picometer. Now electron deficient compound. Incomplete octet in central atom. Example BCl3, which is electron deficient. Dot line electronic configuration both count the number of electrons. Covalent bond, boric acid and diboron, you know, B2S6. So what is the boric acid? H3BO3, incomplete octet in central atom. Lewis acid accepting electron, not protonic acid. Proton donor, weak acid. You can see H3BO3 react with water forming BOH4. You can see the structure of BH4. The structure of boric acid combine and this with main boric acid and it releases H+. So you see the groups 13, 14, 15, 16, 17, 18 and you can see the metals, metalloid and non-metals. Group 17 halogen, group 18 noble gases. So you know the boron family, boron, aluminium, gallium, indium, thallium. Carbon family, carbon, silicon, germanium, tin, lead. Nitrogen family, nitrogen, phosphorus, arsenic, antimony, bismuth. Oxygen family, oxygen, sulfur, selenium, tellurium, polonium. Halogen family, fluorine, chlorine, bromine, iodine, strontium. So general electronic configuration NH2NP1. You can see carbon family 2p2, 3p2, 4p2, 5p2, 6p2. Nitrogen family NH2NP3 2p3, 3p3, 4p3, 5p3 and so on. Oxygen family, general NH2NP4. You see in case of oxygen 2H2 2P4 and so on. Halogen family NH2NP6, you can see fluorine 2P5 and so on. Now noble gases, you can see NH2NP6 and neon 2S1 2P6. General electronic configuration NH2NP6. So this group is composed of stable gases, otherwise known as the non-reactive or inert element. They have 8 electrons in the subshell. So helium, neon, argon, krypton, xenon, radon are noble gases. So general electronic configuration NH2NP126. Electronic configuration of 13 elements occurrence. You can see the boron less than 0.0001%, borates form, borax and orthoboric acid. Borax is important compound Na2B4O7 10H2 and orthoboric acid is 3BO3. So now occurrence of aluminium, you can see fourth most abundant 8.3%, bauxite Al2O3 2H2O, cryolite Na3AlF6, mica, this is the formula, Kal2Si2O10OH. Now friend, less abundant gallium depth thallium, highly reactive. General trend in group 13 elements, boron family, you can see the boron family include the boron, aluminum, gallium, indium and thallium. Physical properties of boron family include silver, good conductor of heat, good conductor of electricity. Boron is a metalloid, the other are metals, very important, very abundant in earth crust, low density, lightweight. Now friend, you can see the chemical properties, actions of air. So O2 and N2. So boron, aluminum in a crystalline form are not reactive. So E react with O2, it gives E2O3 type of oxide. Down the group, the reactivity of boron family towards oxygen increases. Amorphous boron aluminum on heating in air forms the corresponding oxide and nitride. Oxide you can see E2O3 or En. So action of air, E2O3 formations, En formation, and B2O3 react with water forming orthoboric acid. So B2O3 acidic, Al2O3, Ga2O3 gallium oxide, amphoteric, and En2O3, INO3 and Tr2O basic in nature. So chemical properties, the aluminum react with water form aluminum hydroxide, release hydrogen gas. Pure boron does not react with water. Only aluminum react with boiling water. Aluminum decomposes boiling water, evolving hydrogens. So you can see boron, aluminum, gallium, indium, thallium, pure H2O, cold H2O and hot H2O, and little more reactive than gallium and form oxide on its surface. So chemical properties, action of halogen. You can see EX2, MX3 formations, MX3 types of halogens, where X is fluorine, chlorine, bromine, iodine, and E group 13 elements. All these trihalides act as bases. So anomalous behavior of boron, absence of d block, d orbitals, very small atomic size 88 picometer, very high electronegativity 2.0, very high ionization enthalpy at 801 kilojoule per mole. So boron and other elements of people. Boron is a hard black colored nonmetals, and this is soft white metals. Boron show allotropy, other elements do not. Boron has highest melting point, boiling point. Melting point volume lower than the boron. Boron forms only covalent bond, form both covalent and ionic bond. So oxide and hydroxide of boron are weakly acidic. Aluminum oxide is amphoteric, whereas rest are basic in nature. Boron hydride is stable, hydride are unstable. So boron can react with active metals like magnesium to form borides, magnesium borides, and do not react with metals. So Ionic radii increases from top to bottom. Electronegativity, measure the tendency of an atom of an element to attract pair of electrons. So, electronegativity from boron to aluminum and from aluminum to thallium. So, as the atomic radius increases, the tendency of nucleus to attract electrons decreases. Poor shielding by D and F orbital increases, electronegativity increases. So, you can see boron 2, aluminum 1.5, gallium 1.6, indium 1.7 and thallium 1.8. So, electronegativity boron to aluminum decreases and from aluminum to thallium increases. That one is decreases and then increases. So, atomic radius increases from boron to aluminum, decreases from aluminum to gallium, marginal increases from gallium to thallium. So, ionization enthalpy. Amount of energy required to remove the most loosely bound electron from the valence shell of an isolated gaseous atom. Ionization enthalpy from boron to aluminum, ionization energy decreases from aluminum to thallium, there is a marginal decreases. Gallium, presence of 10d electrons, poor shielding, valence held tightly, ionization energy increases slightly. In d electrons, the screening remains the same but size increases. So, ionization energy slightly decreases. Thallium, poor shielding by d and 14f electrons. So, ionization energy increases considerably. So, boron, aluminum, gallium, indium, thallium, the trend is like that. So, oxidation state of group 13. Group 13 NH2 NP1. So, 2s contains 2 electrons, 2 p1 electrons plus 1 oxidation state and excited state 3. So, oxidation state group 3, group 13 element NH2 NP1 general formula and ground state plus 1 and excited state plus 3 oxidation state. BCl3 stability plus 1 increases and thallium chloride. So friend, group 13 boron plus 3 oxidation state, aluminum stable in plus 3 oxidation state, thallium plus 1 in not pair effect, thallus and thallic plus 3 oxidation. So thallus univalent stable and thallic trivalent state. So thallus and thallic oxidizing. So AlCl3 behaves as Lewis acid by forming dimer. You can see that bridging chlorine and for terminal chlorine. So physical and chemical properties of boron family. Physical properties: boron is non-metal, atomic radius 88 picometer, hard, ionic radius M plus 3, black colored, plus 3 oxidation state, crystalline hard as a diamond, poor conductivity of electricity, amorphous, is reactive, highly ionization enthalpy, highest. Occurrence: chemical reactions of aluminum. You can see aluminum, third most abundant element in the earth crust, weight 44.5% oxygen, 27.7 silicon, 8.3% aluminum. So, gallium, indium, thallium less abundant, gallium with low melting point and could exist in liquid state during summer. So, physical properties of aluminum: bright silvery metals, high tensile strength, high electrical and thermal conductivity, from alloys with iron, nickel, cobalt, they form alloy. So, uses: chief constituent of silvery paints, anhydrous AlCl3 used as catalyst in Friedel-Graf reactions, aluminum sulfate used to make fireproofing clothes, alum used in purification of water, used in slicing of paper, and septic to stop bleeding, used in dyeing and tinning of leather. Now, introduction of group 14 elements occurrence. So, I will talk this occurrence in my next video. If you like this video, then subscribe my channel, and thanks for watching.